the only 20 group actually focused on technicians, where we're going to make this available monthly. We're very excited about being here with 3M today with Sean and Ryan to answer your questions about 3M, seam sealer, adhesives. We've got a ton of props. We've got tools and equipment and product and material prepared for your questions. Using the chat feature through the Zoom meeting, use that to submit your questions to Ryan and Sean, and we'll try to get them answered in how they come in. If you want to send it to me privately, that works. Otherwise, feel free also to do it through the group one. Right now, I'm having a little connection issue with my Zoom meeting, but I do want to, before we get started, I do want to again emphasize appreciation for 3M hosting us today for this. This is a monthly technician 20 group, again, the only one that's dedicated for technicians. We'd love to have you join us each and every month, where we're going to bring in subject matter experts from tool, equipment, material manufacturers. We're going to bring in vehicle manufacturers to answer your questions. To sign up for it moving forward, go to collisionhub.com, go to the store and click on subscriptions. That'll give you the rundown of the collision repair that technician 20 group, as well as our estimating 20 group and our owner manager 20 group. Or you can become a VIP member and join all 3 of those 20 groups on a monthly basis. So I'm going to start off with the first question that we get quite often, because I know we're going to set the stage here for a little prop that we've got going on. So when it comes to cavity wax, we get a lot of questions from time to time. How do I know that it's actually creeping in there and it's actually working? So what can you guys give us some information on that for?
Yeah, so that's a good question. Okay. It's a lot of times when we get this question, it's in regards to sort of the weld zones after we've replaced a frame rail or done any type of welding, operation. Could be a section frame rail. So what actually happens when we refer to a capillary action, right? I mean, capillary or wicking action, and so we how do we demonstrate that? And so what we've done, we've come up with a really cool prop here, and we're going to kind of start this off, and we're going to sort of visit back with this, right? And so Sean and I kind of worked on this, and to show you guys there's really no voodoo magic going on here. It's just a steel coupon, an ICAR coupon. We're all pretty familiar with that, and a glass plate in front of it. And I've got some fresh cavity wax material here, and we're just going to set it in there like that, and we're going to come back to this in a little bit as we're talking about some of these adhesive operations and seam sealer operations. But Sean, that's really sort of becoming a bigger question is how do these areas get protected?
Yep, and that's how that product was designed, was kind of twofold: to be heavy enough to stick to your vertical surfaces if you did some unispotter work you're trying to protect on the inside of a panel, but yet thin enough that it's going to wick up into those areas. And it does both, and you're going to see very well with this demo how that wicks up in there with that capillary action. And
you bring up a good point as far as that sticking to all the surfaces. So commonly we hear guys that they'll use a particular brand because they know they've got enough in when it's running out all over the floor. And I usually follow that up with, if it's all over the floor, how do you know that you have any protection in the car, or what's even left in the car to protect it? And so kind of the science behind our product is that it allows it to stick and hold to those surfaces, and part of it is kind of a foaming action that takes place when you apply it with the cavity wax wands, the wand kits, and it's so that it touches all those metal surfaces, and it allows this action to actually kind of kick in and get all those bare metal surfaces covered.
Right. A good way to check that, you can take a clear water bottle and use the wand and spray it into that water bottle. You'll see it sticks to the sides of the water bottle really well, but if you give it a little time, all of a sudden you'll see a little bit of thin oil start to run down to the bottom, and that's the oil that's going to soak up into those areas and protect those other areas. You want to grab that one cavity wax down there by Jason, so we can show that. And you can see here, after, when you first spray it in, it looks a little foamy and a little taller, but once it sits for a while, you'll notice that it just basically turns into like a wax coating. It almost looks like this was dipped in wax. So I know it's not real easy to see here, and you can't really see a whole lot, but these two rails, if you compare one to the other, one had the cavity wax, one did not have any cavity wax. So you can see the difference after these went into the salt spray test. Tip it up a little bit. There you go.
There you go.
So you can see a stark difference between the two, right?
Yeah. Okay. I noticed when you touched it, right away you kind of went for this in your finger, because now you've got it stuck to your finger. One of the other added features that's awesome about the product is it never cures.
Right. It'll stay sticky. It'll self-heal. Right.
Yeah.
So if you do scratch it, it'll actually flow back into that.
Cars are flexing and twisting. You know, to make sure that these areas stay protected so we
Yep.
don't have corrosion
Okay.
built in there. So
Well, let's go and we'll make sure we revisit that at the end of the session and see how far that creeps up and take a look at that.
absolutely.
Got any questions coming in, Jason?
Nothing yet.
Okay. You know, another one I'll set the table for a little bit here is we get questions about our foam cartridges sometimes. And I've got a foam cartridge here. And one of the things that we hear and that we see is that the foams, because they're expandable, if you leave the nozzle in place, sometimes the foam will continue to foam up. The two chemicals will continue to react and react down into the neck of the cartridge here and cause some problems and harden up. So there's actually a couple solutions we have for that. So Tom, I'm going to come over by your camera here and show this. And Ryan, could you hand me that applicator gun?
Yeah.
So we've got two different style of applicator guns here. And one of the things that you can do so that you don't just use a very small amount of that foam partial cartridge and then have to throw it away, okay? So I'm going to show you a couple little tricks that we can do to keep that from happening. So of course we always want to make sure that we equalize the cartridge. And I'll show you a sample of that, why we need to do that as well. But once I load this in here, first of all, I always want to look and make sure side A and side B, out of those outlet ports, that we have material coming out that's liquid, that isn't solid and going to clog anything up. No chunks in there. I always keep a little pick in my top drawer of my toolbox. If there's anything in there, I just pick it out. So we want to make sure there's no obstructions in there. And then gun a little bit of this out. And you can see it's flowing out nicely. I can put my nozzle on. Extrude a little product out. And that's going to foam up. Now, if I'm done using this, I don't want to hit this button on the back and take the pressure off. I want to actually leave that pressure applied to the cartridge and let that sit for at least 5 minutes. So it's going to continue to foam out of here, but that's just the product in the nozzle reacting. So now if I just let that sit with pressure on there, it's not going to allow it to foam back into the cartridge. And I've actually got a couple cartridges here where that didn't happen, and some of these plungers, as you can see by this one here, are now uneven because the product foamed up and pushed one of the plungers back in the cartridge. Okay, so that's the danger of that. So now if we don't equalize the next time we use this, we've got uneven material coming out. So that's one trick. Now this applicator gun here, one of the features of it is that after I'm done pulling the trigger, you can see that the plunger here slightly retracts, so it won't keep as much pressure on. So with this one, you want to leave it in that mode with pressure on there for a good long time, 10 minutes or so. But if you still continue to have problems because it does back off a little bit, that's when I would recommend reinserting the red plug back into the cartridge. Now this one's pretty messy. Sometimes I actually save these from other cartridges that are really clean, but if you do happen to put this back in, make sure that you clean it up good and then align the black with the black side and the caramel side with the caramel side and insert that back in. So I'll just do that quickly. You got some questions coming in, Jason, now?
Yeah, we do have one coming in, so when you're done with that,
Okay.
we'll hit that question.
So if I take this off, I can already see it's clean in there, and it's actually pushed back just a little bit, which is fine. So I would clean this a little better than I have time to do right here, but I'll clean it up. And then insert the caramel side to the caramel side here. Push that in. Sometimes you get a little overflow coming out of there, and clean that. And then you can put your collar back on. So now this cartridge is not going to be foamed up down into that neck. Okay, so two methods. Leave the pressure on there. If that doesn't work for you, you can always clean the red cap and put it back in, and you won't have a problem. Okay?
Awesome, thank you. All right, so here we got our first question. Does the type of applicator gun affect OEM textures I can match?
So that's a good question, the one that we get quite a bit. Yeah, so it can. It depends on what it is you're trying to achieve.
Jason, when they say type of applicator, are they talking about pneumatic versus manual?
If that question person could answer that, so you're talking manual versus pneumatic applicator gun?
And then I guess there's different types of manual applicators. So I'm assuming they're trying to achieve a certain look or a bead
That is the
texture.
question,
Maybe
yes.
if they can chime in on exactly what they're looking for, because there's a variety. You can see by the board behind me, there's a variety of textures that we can match using different applicators. So some of these, yeah, you have to use a certain applicator to achieve that look, right? The beauty of a lot of our products is that we have a lot of different applicators, and some of them you can achieve without having to, buy an expensive, pneumatic applicator. But there are certain beads on this board, such as these two here, where you're going to need a pneumatic applicator to actually replicate that bead. And moving forward, as the seams sort of are evolving, moving into the next few years here, that's going to become more important to kind of get that robotic look that the factories are doing.
So Ryan, part of the reason is if you're using a manual gun, you have to re-trigger and you get the brake in there, the chatter in there, right?
So some of them you have to re-trigger. In the case like you were just pointing out, like this one actually has a thumb release on it, right? So you have to make sure that you're releasing it at the right point. Others, like this particular one here, has that automatic let off. So as you're dispensing material, each time you let off the trigger, it's automatically kicking back. But it becomes a lot more difficult in certain instances. So like if you tried these particular beads here with a manual applicator, you're going to end up with Popeye arms by the time you get done what you're trying to do. In that case there, maybe the investment in a pneumatic applicator is actually probably going to be your best bet.
Now I saw a preview of some videos that were shot with Ryan and Sean not too long ago, dealing with different types of beads that are going to be released here in the next months, within the next several months. So I definitely say check out the 3M YouTube page. Subscribe to that and click on the notification thing so when we get them released.
Subscribe to the channel.
You subscribe to the YouTube channel, get the notifications on that. So Ryan did a great job explaining a lot of different types of seam sealer applications and how to get desired textures and a lot of that. So that'd be a great place to go for it. So we've got another question coming in here. I'm going to give you a preview on this one, so we're going to hit you right off the spot here. So the best thing or steps to use when a baffle on the quarter, the OEM wants the foam back and there are no axes installed. Foam starts expanding very quickly. So,
okay.
So run that.
So no access into an area, they're saying?
Yeah, so when the baffle on the quarter panel, the OEM wants the foam back and there's no access to install. How do we get that foam in there?
Oh, this is the one we got just like a couple weeks ago.
Okay.
I'm guessing it's probably similar to the GM application and the Honda application we got when they're talking about weld sealing with that foam inside that.
Okay. I'm thinking like a sail panel kind of thing where they want to get it into a sail panel and there's like maybe something in the way there.
Okay.
Okay. There's a couple things, and by the way, Ryan, why don't maybe talking about the applicator, maybe you could set up while I'm talking to get ready for to run out a bead like that and show a pneumatic. So there's a couple things you can do, and some of it depends on the type of welding you're doing too. Okay. If you're MIG welding, you really need to be careful about MIG welding anywhere near any foam, right? If you're spot welding, it's not quite as a concern, but it's almost impossible on a vehicle nowadays to put the foam in ahead of time. I get what they're saying is that, if let's say you are doing a sail panel and you put foam in there ahead of time and then you put the panels together and then start to weld, I mean, you could have a fire or whatever. Yep. So we don't want to do that.
Or maybe the panel doesn't even fit because there's too much foam in there potentially.
Right. So if there's no access at all, we really don't have a great answer for that, to be perfectly honest. However, there are a lot of different ways, like on a sail panel, a lot of times you can access from even remote areas. And one of the things we talk about or recommend is on a cartridge with a nozzle, Not the best example, but with a nozzle, you can get some, you can just go to the hardware store and get, it's called medical tubing, and it's a clear plastic tubing, and you can use that to try to get to some of those remote locations. So maybe there's not a hole right by the sail, but sometimes further up into the roof rail or other area, you can get it from more of a remote location. There are, again, other possibilities, especially if you can keep that foam away from it, right next to where you're welding, where you're not concerned about it burning or anything like that, is you can pre-make some foam. And let me grab something here.
Okay. And while he's doing that, yes, the question was related to the sail panel. So just
it was. Yes, it was. Sail panel. Okay, perfect. So one of the things you can do, and by the way, Kristen and I made a video of this that's on YouTube. Okay. If you look up 3M foams on YouTube or on our YouTube channel, we have a really good video showing putting it in, foam in from a remote location using a water balloon like iCar does, right? So you could do that, or you can pre-make your foam. So let's say it's a flexible foam, and I don't know how well you can see that, but I've got some foam here where you can actually extrude the foam out onto some plastic or something that's where you can remove it again. Another solution, excuse me a sec, is packaging tape. So if you extrude it out onto some clear packaging tape and allowed it to expand, and then trim it to the size of whatever cavity you're putting it in. This is before you put the new panel on, and then you can use the NVH foam, the 4274. Is that it?
Oh, look at that.
So you can use the 4274, which doesn't really expand. It's more of a like a windshield urethane type consistency. You could butter up that part and stick it into that sail panel, and then close out your area that you're going to replace the panel with. Okay, so sometimes making the foam ahead of time. And by the way, another thing that works good is if you're putting foam down in, let's say, a B-pillar, and you don't want it to run all the way down through, you want it to stop halfway. One of the things you can do is use this foam again to make like a little dam that you can stuff into an area or the bottom or wherever you're working. And this is all on that video, by the way. So you could stuff that in and use that as a dam so that when you do extrude your foam down into that cavity, it'll stop at that dam. So a lot of little creative things that you can do, and there's a lot of things we touch on in that video.
Okay. Ryan, what do you got going on over there?
So I've got a couple things queued up here. I'm assuming that they're talking about some of these more unique beads, these ripple beads and so forth. And so I kind of set one of these up to kind of set the stage for this here. I'm going to have Tom zoom in on what I've done here. First, I'm going to start with a pneumatic. This is our sausage pack offering here, and I've cut this tip at about a 30-degree angle, and I've actually used a duckbill vice grips to clamp that. And the reason why we're doing this is that we want to be able to use that tip right onto the surface. This is actually going to be our guide. And as we're dispensing this, we're forcing it into the surface. So once I get my applicator, my pressure set up here, we can create that ripple look or ripple effect with just a couple simple motions. And the beauty of this is that we can manipulate these tips, these tips to do several different things. Now, to the question of can I use a pneumatic or a manual, certain applications we certainly can. So now this one I've actually put a little dimple in the end here to replicate sort of the ripple beads that have that dimpled look. And this is just our 1-part urethane. And I've overdone the dimple on that, as you can see, but it gives you an idea of how we can replicate that look, right, and what we're trying to achieve. One of the really cool things is that we have a lot of versatility with the offerings in sausage pack versus cartridge tubes, 1 parts versus 2 parts, that we can replicate these. But one of the things I'm going to do, Sean, if you don't mind.
And by the way, you are using just a 1-part.
This is just urethane. A 1-part urethane, and so one of the misconceptions that we get a lot is, you know, I don't want to use your 1-part urethane because it takes too long to cure, right? And that's true in most cases, but it's paintable in 30 minutes. That cure process will still continually work while it's underneath. But
so I always think of like areas like if you put a couple quarter panels and a rear body on a vehicle, all that stuff on the inside that you need to seam seal, why use a 2-part cartridge when you could use a 1K? you know, it's much cheaper for one thing, and you're not really worried about it curing immediately.
And if we're actually following the OE process of how we're applying our seam shears to really achieve that factory look, we'd be putting them over a 2K, you know, factory match sealer to begin with, and then you can use your 1K, let the overspray fall inside the car, and sort of replicate that. But one other thing that I wanted to do quick is I'm going to have Sean hold this up, is that we're able here, we'll make it even more fun. We'll hold it over your head. So one of the things, so if you ever replace like a frame rail on a vehicle and you're laying down on the ground underneath, we're able to replicate this right onto the vehicle, and you can see that it's not falling on me at all here, right? But we've got that ripple bead technique. And one of the ones that we commonly get questions on is particularly Toyota, in fact, because they have sort of a hardened exterior and a soft interior. It's almost like a foam, and it's a gray material. So our MSP closely replicates that in both texture and feel once it's reapplied to the vehicle, and it's the same color as what Toyota had originally.
And just clarify MSP. So it's very similar to a urethane.
So it's very similar to a urethane. A urethane is a really viscous paste, right? It's a little bit thicker. Some people will say, well, I don't prefer it because it's too thick, kind of sticky a little bit, which is kind of, it goes back to what the technicians are used to working with. So we offer an MSP sealer, which is a little bit creamier. Right, it gives them a little bit, you know, more flow to the product.
More of a mayonnaise kind of consistency.
Yeah, exactly. But it's still got a heavy enough body where we're holding our textures and our shapes that we're trying to replicate.
Easier to brush, easier to tool and shape.
Absolutely.
Yep. So think about that. MSPs, a lot of guys don't really know what that is. So.
Yeah.
Yep.
And as a follow-up question, the tips that you're using on there, that's just a 3M tip on there?
Just a 3M standard tip. Yep. Okay. Available with all of our stuff.
Okay, cool.
So he just pinched it down with a
Yep,
duckbill and flattened it out.
So I'll actually show you guys real quick. I don't know which camera's looking at. Maybe Tom can zoom in and take a look at this. So here's what this is just our standard sausage offering, and this also works in the one component for the cartridge, but I'm just cutting it at about a 30-degree angle. Okay. If I cut it too steep, you will have material that'll work back out around the bead that you're trying to replicate. And then I'm just pinching it about an inch back from the front. Okay? As I pinch that, I just want to make sure that the plastic stays formed, so I usually give it 2 pinches, about a 1/4 inch back from the first one. And I always want to leave it in an upright position with the longest part of the cut being at the top. This allows me to, like you saw, hold the tip right onto the surface of the vehicle. Okay, so this is the tip. This is what we got cut here. And by doing it that way, we're forcing into the substrate, so we're creating a nice tight bond and a tight seal with the surface that we're trying to seal. So hopefully that answers the question. If not,
I think so.
Elaborate on it some more, I guess.
All right, so next question. Winter has arrived. It certainly has in Minnesota, although it's pretty mild out yesterday and today. But when working with adhesives in colder climates and this time of year, can I warm those tubes up at all? Can I put them in water? What advice? And conversely, what if I'm in the heat of Arizona in the summertime? What can I do to?
So that's a great question. And just to give you a little background to begin with, remember that working time, which is what we're really worried about, right? So our working time is heavily dependent on temperature, and everything that we do, we test to 70 degrees, right? Room temperature. But every 20 degrees hotter will cut your working time in half. Every 20 degrees colder will double the amount of working time, roughly speaking, right? So you can take advantage of that by warming the cartridge or cooling the cartridge, depending on the climate. So let's take the hot weather, or let's take the cold weather like the question was. So for cold weather, you know, one of the things, if your shop is cold, typically the people in the office are comfortable at 70 degrees, right? So you can take it in the office and plan ahead a little bit and put it in the office where it's warmer. Or sometimes they have a storage room where the storage room is a little warmer. They have a compressor in there or something, and you know. But another thing I used to do is just put it in my pocket for a while, like, you know, put it in your back pocket or whatever for 15-20 minutes while you're getting ready to use it, and just warm it up a little bit. So, you know, a good idea to have like an infrared thermometer, kind of check that temperature and see if it's getting warm.
So one of the things that you mentioned, which is good, is you want to be able to cool it and warm it over a little bit of a period of time. right? You don't want to take your heat gun and warm up the cartridge because the outside is going to be warm, but the inside will still be cool, and you'll get inconsistent keyring throughout the repair, right? So make sure that if you're going to put it in the office, it would be a great opportunity to say the night before you go home, put a few cartridges on the desk in the office, and then come in the morning, and if the office stays at 70, great. If you're going to put them in the refrigerator to cool them down for like 20 minutes, 30 minutes, bring the material down to a cooler temperature if it's a warmer climate, and slow down that reaction.
Okay.
So as far as colder temperatures go, or I'm sorry, warmer temperatures go, you can cool it down, okay? But think about it, your work time's gonna double. So you're using an adhesive for 90 minutes. Now you've got a lot of time if you double. So I wouldn't go any colder than like 50 degrees, right? So going from 70 to 50. You don't wanna go anywhere down below 50, but even going to 50 will double your work time.
It also doubles your clamp time.
Clamp time
So
as well.
the clamp time and paint time are key and that's with all of the two-part products, seam
Right.
sealers and
But again, if I'm
adhesives.
in a hot climate again, maybe bring that stuff to the front office.
Yeah, in the
Or-
air conditioning or whatever. Don't just teasing the office people, you know.
Not a problem. All right, so another question we get from time to time is the difference between the impact resistance of structural
Oh.
adhesives and panel bond adhesives.
Sure.
Can you give us a little insight into that?
Yeah, really good question. So, you know what? Let me queue up. I've got a video. If
I'll queue
can
it
you
up if-
find it?
yeah.
Okay. So I have a video we can play that really talks about the difference between the two adhesives. But in the meantime, if you stay with me, this is a great example of the difference between a structural adhesive and an impact resistant structural adhesive and a panel bonding adhesive, okay? So the numbers tell the story. So the impact resistant structural adhesive has twice the peel strength, so double the peel strength and triple the impact strength. So right there, that just tells you they're very different. Now, the way it really works, and you'll see in the video, we do a wedge impact test where we drive a wedge between two pieces similar to this, and we drive a wedge in there and see what kind of force it takes and the amount of time it takes to separate those two parts. So that's the big difference between the two, and you're going to see that a typical structural adhesive, like a panel bonding adhesive, comes apart well before the wedge makes contact with that area, whereas the impact resistant adhesive does not split until the wedge actually drives it apart and makes direct contact. And what that does is it allows the panels, the steel or aluminum, to stay together longer so that it can absorb more energy as it crushes. And you can see obviously here, this absorbed a lot more energy than this one here did, okay? So it is somewhat the strength of the adhesive, but it's the strength of the adhesive enhancing the ability of the steel to absorb energy, okay? So you got that ready to go?
Yeah, we're all
Let's
ready
take
to
a
go
look.
here.
This will be a good explanation.
Marcus, you ready to go there? All right.
Repairing today's vehicles is so much different than it was even a few years ago. Cars today are made using new methods and materials. They're assembled with different combinations of welds,
I know Ryan knows that
and
one.
adhesives for added passenger safety. More than ever, car makers are designing vehicles to specifically manage crash energy, directing it along specific planned and tested paths, helping protect vehicle occupants during a crash. When repairs are required, these vehicles must be repaired according to the rigid standards set by all car manufacturers. This is why 3M provides our impact-resistant structural adhesive. It's developed and tested specifically to help you repair vehicles to manufacturer repair standards. Watch this dynamic wedge test. Here, a wedge is driven into a bonded joint to simulate the forces the adhesive experiences during a crash. This typical structural adhesive fails almost on impact. It no longer works with the surrounding substrate, and it can't help absorb and direct crash energy as it was designed to. Now, the 3M impact-resistant structural adhesive. Its toughness allows it to transfer the impact energy to the substrate over the entire joint area. Notice how the substrate curves away as the crash energy is absorbed. The force is managed according to the original vehicle design for passenger safety. Here's the difference between impact-resistant structural adhesive and a typical structural adhesive. Impact-resistant structural adhesives include special tougheners in their chemistry. During a crash, these tougheners slow down the progress of cracks and help prevent bond failure. Without tougheners, cracks progress faster and deeper into the bonded joint, negatively affecting crash energy management. 3M adhesives are designed to meet OEM repair standards. In fact, 3M is referenced in OEM repair procedures for panel bonding and impact-resistant structural adhesives more often than any other adhesive supplier. Help ensure safety by meeting adhesive standards set by car makers to manage crash energy and protect vehicle occupants. Always follow original manufacturer repair requirements and choose 3M structural adhesives for your collision repair where called out. When impact resistance matters, trust 3M.
All right. Anything in conclusion on that, Sean?
No, I think that pretty much says it all. The only one thing I do want to caution about is sometimes you'll see where a car maker will recommend an adhesive and say or equivalent.
Yeah.
Okay, so we have to be very, very careful about that because typically, unless you're a chemical engineer, it's pretty hard to tell whether an adhesive is exactly equivalent. I just did a presentation where I showed an OEM spec sheet for structural adhesive, and it was 97 pages long of tests and qualifications to spec that in. So you could imagine something that's just slightly different may be a completely, may react completely different in a collision. So when they recommend an equivalent, I'd be careful about it. Okay.
If they're calling something out, just use that.
Okay, I'm sorry. Yeah.
All right, cool. All right, so next question, want to handle the primer one? That good?
Sure.
All right, cool. Next question, what about primer before seam sealer, and which primer should you use?
This is my favorite question. I absolutely love this question. So we get this a lot. There's a lot of confusion around this topic in general, right? Do I prime before seam sealer? What primer do I use? Perfect question. I love this. So from the factory, the process to which they're building these vehicles, it's an eco, right? So they're dipping these vehicles completely, and it's not something that we can replicate in the aftermarket. We can come very close by using 2K, direct to metal urethanes or epoxy primers, and we always recommend an epoxy primer. What I want to show you over here is a couple panels that we have. When we bring people in for training, we have them actually build these panels, right? On this side here, we have a 2K epoxy primer that's been applied, and to show the value in this, we only put one coat on this side of these panels to show the strength of the product. And this particular brand actually recommends 2 coats. To be corrosion resistant, you got to meet a 500-hour salt spray. So what does that look like when we use a 1K? So we built these panels, we put them through the tank, and we let the people that come in choose which 1K product that they want to put on this other side. And so when we let them choose and then we put them through our tank, the minimum requirement, we find that these 1K sealers are failing and failing quite often, right? We haven't had any that have been substantially great because there's no catalyst in the product. It remains in a soluble state. I could take lacquer thinner, I could soften this at any point and bring it back to a liquefied state. So we recommend that all seam sealers, even direct to metal seam sealers, be put over a 2K epoxy primer because this is how we're going to ensure optimal corrosion protection in these areas. So when it comes to priming, a 2K primer is absolutely what we're recommending. A 2K epoxy is best. They might be a little bit slow compared to like your 2K acid etch and 2K urethanes, but you can use a cotton dauber to brush these on. And one of the important things to point out there is that if you're using a 2K acid etch and then a urethane primer, is that you're not skipping, and this is key here, Jason, they're not skipping the urethane primer part. A lot of guys will put on the 2K acid etch, then they'll apply the seam sealer, thinking that the metal's got appropriate protection, but it doesn't, right? That acid is on the surface it's waiting for to marry with the urethane primer. So it's actually 2 processes in which the primer has to be applied versus a epoxy primer, which is strong. And in most cases, the OEMs, in fact, will specifically state a 2K epoxy primer is the only way to replicate an E-coat similar to what was done at the factory.
And by the way, that's not brand specific. It doesn't matter what seam sealer it is. You put it over etch primer, it does not get good
Absolutely.
adhesion.
It doesn't, the two chemistries don't match up, and it'll either cause the seam sealer to delaminate if it's put on top of it, or it's going to cause the paint to delaminate if it's used on top of the seam sealer. So go back to, if we're putting a seam sealer direct to metal and we don't have an epoxy primer or epoxy sealer on our mixing bank, the next step is that metal has to get covered, so they're using an acid etch primer that goes down first and then a urethane on top. Well, that acid etch primers come in contact with the urethane, the chemistries don't work. Okay. And to Sean's point, it's not, you know, specific to 3M.
Okay.
Right? It's just a general, you know, rule that needs to be followed.
All right, another question for you, Ryan, here. Do you recommend a skim before duplicate?
So before you spray, a skim of the seam sealer, right?
Yes. So in most cases, yes, and I want to show you over here what that looks like if you guys aren't familiar with this. So in some cases where you're getting your panels that are, they're very dissimilar, right? I like to use this reference and like the Lexus Toyota, the rear body crush cap areas. We absolutely do recommend, when you're going to try to replicate that look, that your first step would be, so like if this is our crush cap, and I'll just kind of draw a figure around here, that I would seal that seam first, right? A lot of guys are familiar with the acid brush. I actually prefer using a spreader, right? So I'll cut down a spreader to a smaller size, and the reason being is that it helps to force the material to the surface. I haven't created any, you know, gaps or voids in that product, but then I can come back over the top of that and I can create the look that I want, and I know underneath here I don't have any problems. Now, would this work if I didn't put down that skim coat? Because of the application in which you saw that I did here, it was you know, it was forcing it to the surface, right? So I'm creating a tight seal. Similar to the way I did with this applicator, is that I'm forcing it to the surface as I'm dispensing it so that I don't have voids underneath. But in the case where you have a lot of panels that are stacked up or dissimilar metals that are really thick, absolutely I would recommend that you would put down a brush, you know, coat first, a skim coat, to make sure you've got a 100% seal on that seam before you do your bead replication.
Kind of anywhere you have a concern, like, is it really getting in there and sealing well? So similar to seam sealer tape, which we don't really care for because it can bridge that little gap, you know, or that little difference between the two levels of panels, right? So yeah, it's the same kind of question, isn't it?
Same kind of question, and to your point, the seam sealer tape, I'll throw this out there, and if anybody can answer it before I get to the end, I'd be amazed. But if anybody can tell me that hasn't been through one of our classes where seam sealer tape originated from, you know, bonus points to you. Jason will send you a hat or something. But anyways, so we do sell a seam sealer tape. We don't recommend it, and the reason being is that there's a void along the hem flange area, right, that just can't be sealed. You can use the tool, you can work it in there, you can, you know, roll it, heat it, shape it, whatever, but inevitably there's always going to be that gap right along that hem flange. I see Tom's got his, no, where are we going? All right. It's all right, Marcus. So along this whole flange, there's always going to be that void, right? So one of the questions that we get is, how do we how does 3M, you know, recommend that we replicate that? And it's going to be with our 5887 material, right? We're going to scuff the surface, we're going to, you know, tape out the desired width of our bead, and we're going to apply that material because it has a sag component to it. Not only will the edges lay down nice like the factory, but that hem flange is going to be sealed completely along that lines. Awesome. So that's kind of the shortened version of it. We don't recommend seam sealer tape for that reason, and it's really not meant to be stuck to the surface.
And again, another quick plug back to the 3M YouTube channel. Again, that's some other videos that will be coming out with Ryan talking about duplicating some of those seams as well. Now, Sean, question for you. I know you've got the answer because we've talked about this one before. What's the difference between 8115 and 8116?
Great question. So the main difference, now when we ask that question, a lot of guys will point to the clamp time. because the clamp time of 8116 is a little bit longer, 6 hours instead of 4 hours, right? So, but that's not the main difference. So the main difference is the failure mode. So when we test these adhesives, we do what we call a T-peel, where we put these little plates together, we bond them together, all exactly identically, and we pull these apart, okay? Similar to that wedge impact test, but this time we're pulling them apart instead of driving a wedge through. And what happens is, when we look at this, and you can see on, if you show the screen, you can see the difference between how these parts peel apart, okay? So there you go. So on the left you see adhesive failure, okay? That's typically what we get with 8115. A little bit different than that, more like the one on the right, which we would call a mixed mode failure. But the one on the right where you can see the adhesive didn't come off perfectly evenly on both sides, okay? Now, 8115 has a little higher lap shear strength, okay? It's a little bit stronger, but the 8116 is still plenty strong to meet the OEM standards that they were looking for. So, if again, this is a good view here of these. Well, actually, here, let me just pop it up on the screen. There's 8115 and 8116. So you can see a pretty stark difference there. Now, because the 8115 fails adhesively, you get a little bit more strength, but you don't get the coverage. And the reason behind that is General Motors and FCA, Chrysler, when they did their testing, they saw that when the failure mode is adhesive, that some of the bare metal is exposed on the flange. And if that vehicle didn't get repaired properly, or let's say it just flexed enough to separate the panels but not really cause a lot of damage, or maybe it wasn't replaced, that you've got some bare metal in the flange, it could corrode and cause a safety issue later down the road. But with the 8116, when they separate, you still have adhesive covering both sides. And that's what they were concerned about. So the rule is, when you're working on an FCA vehicle, Fiat Chrysler, 8116. So if you're using 8115 for everything, you're making a mistake on the Chrysler vehicles. And then General Motors used to be the same as Chrysler, but now they changed a little bit recently. They just put out a bulletin a few months back that says they want you to use anywhere adhesives are recommended, structural adhesives, they want you to use the purple, the 7333 structural adhesive on everything except the door skins. On the door skin, they still want you to use 8116, not 8115. So generally, if you're working on GM or Chrysler, you have to have 8116 on the shelf.
Okay. Now, continuing on with OEM recommendations, again, another conversation you have had. If I'm going through the procedures, excuse me, and they're telling me to apply adhesive, which preparation steps should I follow for applying the adhesives?
Right, and that's an excellent question, because occasionally some of the manufacturers may include some of the flange prep information in the OEM bulletin, but the thing to keep in mind is they don't know which brand of adhesive you're going to use. So our preparation steps may be different from somebody else's. So most of the manufacturers will say in their bulletins to always defer to the adhesive maker's instructions, okay? So Honda's a great example. So when you work on a Honda vehicle, right in their repair information, it says defer to the adhesive maker for adhesive preparation. Because some may call out removing all the galvanizing, some may not call that out, some may recommend a more aggressive abrasive than others. So always follow what the adhesive maker says. I know we've conditioned everyone to follow the OEM at all times. This is the one exception.
Well, you're still following the OEM, right? Because they're telling you to
We're the
defer.
OEM
Yep,
for that, right?
Yep,
we make the adhesive,
Yep.
exactly. Yep.
Absolutely. Okay, so keep those questions coming in. We got a little bit more time left, so we'd love to hear some more questions from you. In the meantime, I've got another question for you. We talk about weld-through primer.
Oh.
Can you give me some weld-through primer tips as far as what exactly is weld-through primer? And I noticed you had it laying down on its side. Can you explain why you did that?
Just fell over.
Just fell over.
No, no. The reason I did that is because weld-through primer is basically a zinc powder. Okay, that's the active ingredient, and the reason that is because the zinc is more electrically active than the steel that you're going to spray it onto. Okay, so when I spray this on, there's more available electrons that get transferred to the steel. And as that steel picks up those electrons from this product, it slows down the corrosion process, okay? It's similar to, I always compare it to a water heater in your house. So your water heater at home has a steel liner inside and it's full of water. That would corrode immediately if there wasn't something to stop it. So in your water heater, there's a long rod in there that's made out of zinc, okay? And that zinc rod transfers electrons to that steel liner and keeps it from corroding. So if you didn't have that in there, your water heater would go bad like in a very short period of time, okay? So this is doing the same thing. It's transferring those electrons. Now, obviously the more of that zinc powder you have in here, the better off it's gonna do, right? So our product has a good amount of solids in this can. So when the can settles, all that zinc settles to the bottom. And think about it, you've got a dip tube that comes down that pulls the product from the bottom of the can. Well, if you don't do everything correctly, you're gonna suck up all those solids into that straw and clog the can, right? So that's why I store it on its side. So you could store it upside down as well, but I like to store it on its side. I actually usually keep it in a drawer, which forces me to lay it down so I don't forget. So all those solids are on the side. Now you want to agitate it really well when you're going to spray as well, okay? So, you know, store it on its side or upside down. The solids are always a good thing, but again, they can cause some problems. The other thing that's kind of funny I've seen guys do is we've taught guys pretty well to protect their hands, so a lot of them are using gloves when they're spraying this product. And you have to be careful because sometimes your glove will droop down right here. I see it all the time. And when you spray, it'll hit your glove and you'll see all kinds of spattering. So if the can is spattering, check out your glove. It sounds simple, but I've seen it happen many times, okay? The other thing about weld-through primer that's probably the most important thing is we really shouldn't weld right over the top of it. You know, I know it's called weld-through primer, but it gained that name many years ago before the OEMs took a really close look at it and said, you know, we don't really want that in that molten weld puddle because it's going to contaminate the weld, and basically you're going to have a very porous weld. If you'd shear it in half and look at it, it'd look very porous. So when we prep panels, we really need to remove that weld-through primer from the weld zone, just where we're going to weld, okay? It'll still be in those surrounding areas, but not in the immediate weld zone. So guys always ask, hey, how do we clean that out? And I have a very simple method for doing that. So one of the things we can do here is what I always try to do. Let's say you're putting a quarter panel on the car. You're going to test fit your quarter panel, make sure all your gaps are lined up, right? So before you do your test fit, go ahead and punch all your holes in the panel. Here, I'll set it down, Dan, so I keep it still for you. Sorry about that. So I'm going to punch all my holes in the panel first, and I'm going to spray all my weld-through primer on my flanges first. Now, when I test fit the panel, I can take a marker, and I can mark where every hole is on that. Just takes a couple seconds, okay? Then once I'm done, and I take this off to apply my adhesive or whatever I need to do, now I can easily see where those welds are. So then I'm going to take my file belt, and all you need to do, and we can plug it in, I'll just do a couple quick. All you need to do is just take the edge, little corner, and just clean right on that area. So you can see now I have nice clean bare metal right where I'm going to weld. So it's not like you need a special tool to get in there or anything else. If you plan it, put this stuff on, punch your holes first, clean them off. Really, really simple to do.
Okay.
Anything to add on weld-through primer?
What about copper?
Copper. Okay.
We get that question a lot.
Good question.
I love throwing it out.
And Tom, if you can focus in on this chart right here. Right here. Can you get that? Okay, so what this chart is showing you here, it's showing you the top of the chart are the most electrically active metals. Okay, you see magnesium is way up on the top, and zinc is the next one down. we probably wouldn't want to use zinc or magnesium for weld through primer, right?
It'd make a heck of a 4th of July show.
Exactly. So zinc is the next one down, the most electrically active. So that zinc will transfer electrons to the steel. Now, if you look on this chart, and I'll try to point this out, steel is right in this area here, but copper is down here below the steel. So steel's up here, copper's down here. So what happens is the copper will actually rob electrons away from the steel, and it actually causes corrosion. So the copper really isn't a good idea because it's less electrically active and will steal electrons away from our host panel, which we don't want to happen. That's why we're starting to see even companies that, you know, we're making copper welded primer have now gone to zinc.
Well, and I think the key thing to point out is when copper sort of hit the market and became really popular, Toyota took a really close look at it and said, what is this new product? Why is everybody loving it? And they released what Sean just mentioned here was like, we don't recommend it whatsoever. In fact, if you actually, you know, read the repair procedures, they're calling for a zinc-rich primer.
Yep.
Right? They want the highest level of zinc possible, and if they would allow you to do it, if it was possible, we would just throw zinc powder on the panel before putting it on the vehicle, sure. But we can't do that, right? So we need to have some solvents in a can to deliver them to those flange areas to protect these metals. And then it's important to point out, like Sean said, removing so we get good weld fusion when we're actually going to make the MIG welds and the you know, mag welds.
Let me pull up some pictures of that, Ryan, while you're maybe taking the next question.
Okay, so I know it's a question that Sean's answered for me before, so I'll put you on the spot now. So
right.
Since we've got our file belt center here, what are some tips that you can offer for using this, or even a cutoff wheel, when removing panels, so that we're not getting too deep into our undamaged panel?
That's a good question. So one of the things you can do is on a test piece would be, so like if I had an 80 grit belt on here and I'm removing a weld, right? Actually count the number of seconds to when you get to the actual, you know, where you need it to be. So we're not going too deep into the lower substrate. And then sort of just count that rhythm as you're going down the panel. You don't need to push really hard. I see a lot of guys don't really want to get into it and really reef on it. You don't need to do that, right? And a lot of the other thing too is a lot of guys will use a 36 grit belt thinking that that's going to tear that weld out of there. The 36 was actually designed for bumper repairs, and 60 and 80 were designed for steel repairs.
Okay.
So your 36 grit on your file belt will actually take you longer and cause more problems for you in the next half of the repair than if you use the proper grit from the beginning.
And correct me if I'm wrong too, we're not going to remove the entire spot weld, right? We're going to remove a portion of it and then...
We're looking to, so in this panel here, if you look at this up close, there's 3 spot welds on here. We're looking to remove just where that spot weld is, right? We don't want to dig into the lower surface because then we're going to actually weaken the substrate that we're trying to save and rebond to, and then make sure that our next weld goes next to the original, not on top of it.
So thin the metal, use a panel separator, and then trim out the rest.
That's
of
the
spot
key
weld.
to me is you're really theoretically not even trying to go all the way through the top panel. You're trying to make the top panel paper thin.
Yep.
So with your panel separator, you can finish it, and then you don't go into the bottom panel at all. The ideal cut is when you still have a little high spot where the weld is, not where you have a divot, but the divots need to be avoided.
So one other real quick thing, and to adjust the belts. We get guys that'll say that our belts travel quite a bit. So there's actually a Phillips head screw, if you look here on this side of the actual bar. This screw right here will actually recenter the belt. So we'll get guys that they'll be in a hurry, maybe it falls off their toolbox onto the floor, this gets bumped, it comes out of alignment a little bit, and then all of a sudden they're grinding with it one day and the belt pops off. And they're like, oh, it's, you know, crappy product, junk tool, the belts suck, whatever it else. But maybe it's just that you need to realign that. It comes aligned from the factory, you know, when it's made. But maybe you need to readjust that so that you're getting proper wear on your wheel on the front too.
It's always a good idea to watch the wear on your belt, kind of like a tire, right? When you know it's not wearing properly, you've got some kind of an issue. But that little spring-loaded screw will adjust that.
Well, and equipment maintenance is always important. I don't think it can be overlooked. So, all right, Sean, I want to go back to your your weld.
Sure. So if you can bring up the photo on the screen there. So one of the things when we talk about weld through primer that's really important, again, is cleaning it out of that weld zone. So what this is a picture of here, this isn't a picture of me being a bad welder and not being able to fill the whole circle in. What it is it's the very first strike of the arc. So when you first pull your trigger, it should put out a nice little droplet of material, and that droplet should be attracted to the surface. It should just grab right on. And you can see this is to bare metal, so there's no weld through primer in the way. So you get nice fusion around the edge. You can see by the yellow arrow, really good fusion, a nice round droplet went on there, and it all grabbed on. And look, no soot in the rest of the hole, okay? So that's nice and clean in there. Now, by comparison, this one here is galvanized. So galvanizing, weld through primer, very similar, right? So now you can see it didn't get good fusion, okay? And again, this is just the very first pull of the arc. Didn't get good fusion, and now you've got all that soot and garbage in that weld area. So now think about it. If you're welding, what happens is when you pull the trigger and it doesn't attract to the surface, the wire burns back and forms a little ball on the end of the wire, okay? So that ball then just keeps punching the surface until finally you get a good arc and it makes the weld. But now you're off to a terrible start. You have to try to recover. You spend much more time in the weld zone recovering, and you get a much hotter weld. So go to the next slide. So here's another one. This is zinc. Now you can see it's not quite as bad. You have more fusion, but again, you've got soot in that area, and you don't get that nice round droplet going on there. So you're going to spend more time trying to finish up that weld and have a much hotter heat effect zone by the time it's all done. So, you know, as a technician, you know, if I was welding, if I wasn't welding on real clean metal, I would get very frustrated. You know, there's too much stuff in the way, and it's not grabbing well, and you know, it's just, you know instinctively that welding on nice clean metal is going to be a much easier weld. So a few minutes cleaning that out is going to make your life much easier when you go to do your welding and your grinding, by the way.
Okay. So another question we got coming in. So for those of us that maybe don't use 3M products as often, or maybe we don't see our jobbers often, what are some new products that you've got available this year that you're excited about that you'd like to share with everybody?
I just
That
point to
you- that
Ryan.
you
Just
can
gonna
share.
point to me.
Yeah,
So
what
in
we
our-
could talk about, right?
Yeah, so in our you know, one-step polishing system that we have out this year that eliminates the need for multiple compounds to achieve the polishing job. We've got new tapes that are available. Our new poly tape is out. That's actually taken off like fire. It's going really well. With AC&S, you know, our focus is still adhesives. We're working on a few new things for 2020 in seam sealers, but nothing that we have out today that we can be showing you or demonstrating.
No problem. That's
AC&S. Okay, so the commentary from the background is what's AC&S? Adhesives, coatings, and sealers. So that's where Sean and I. That's our area of expertise is adhesives, coatings, and sealers. So in those areas, we're working on it. We will have something out, but yeah. So our poly tape has actually been one of the most successful things that we've had out in the last, and this is only about a month old right now. So it's been going really well, as well as our one-step finishing system.
And by the way, Jason, for people that want to know about anything new, if you go to our 3M Collision Facebook page and you click on subscribe, you will get notifications sent to you.
Okay.
Yeah.
So anything that comes up, anything new, you'll get notified.
Facebook
we hear
and Instagram, they're
yeah,
posting a lot of
we
the
hear
new stuff.
a lot of people saying, "Oh, we never heard of that," or "We never saw that. Why didn't they send something out?" Well, you're going to get it there first, and it'll get pushed out to you.
Yep.
And as far as the poly tape goes, we just shot a Cool Tools episode last week at SEMA on because I think this is a cool tool.
Yeah.
It tears so easily, and it's. Can you? I got two hands, but can you show them the how like when you go? Well, it's more with the fine line, right? Where the separation on the.
So you just snap it, and it tears off square every time.
And then also when with the fine line tape, as you're going around areas, you can actually see if the tape is stretching. It's kind of built in like that.
I'll have Dan, if you want to zoom in on this, I'll prop it up a little bit so you can see. So when you're taping stuff off, if you bend the tape too hard and too far, you get these indicators that tell you where you might have picket fencing going on in your paint, right? So before you even get paint on that panel, the last thing you want to do is be untaping that car. You pull your tape off and you go, oh man, I got like a jagged edge there. Yep. The tape has an indicator built in to show you that, so that you're going to get a better finish with your end product.
And just for your little editorial here from one of our viewers here.
Uh-oh.
That tape is awesome. Saw it in person at SEMA. So I think it's pretty cool tool. So yeah, check out the Collision Hub YouTube channel as well. You'll see a cool tools episode on that coming out in the not too distant future on it. So Sean, can you give us, this is a cool prop. I know you like this one. Can you give us a little bit of information on what we're looking at here?
Sure. So I'll get over here where Dan can see me. But this goes to flange preparation. So one of the things we want to make sure is when we're using adhesives that we prepare the flange properly. We didn't get any questions on that so far. I'm kind of surprised. But when we're prepping for adhesive, number one, always be really clean, right? You can't clean too much. Just clean everything really well. Clean right before you put the adhesive on. Just make sure everything's cleaned well. Because the whole key to an adhesive is how it wets out the surface, okay? So you could imagine it's like, you know, if you applied an adhesive and it didn't fully bond to the surface where it would bead up or something of that nature, that wouldn't be good. So we want it to really wet that surface out. So using the proper grade abrasive is key. And again, the guys, if guys default to something, you usually tend to default to something that's coarser than they need it to be. Like for example, a 36 grit abrasive, the grains are so far apart that it doesn't really get all the surface area, and you'll see areas like here where you can actually see it didn't take all the galvanizing off in this area. So up this way, there you go. So and then this next one here is a Scotch-Brite belt, okay, the coarse Scotch-Brite belt, which is really great. We've got this listed as one of the tools to use when cleaning for flanges, cleaning flanges off. And then the last one here is a roll-lock disc, okay? The nice thing about a roll-lock disc is because it's so flat, it tends to plane the surface really flat, as opposed to if I used, like, let's say a grade 80 Scotch-Brite belt, it kind of puts, you know, ups and downs in the surface, but whereas that roll-lock planes it really flat. But the one thing we want to really look for is what we call bright steel. And this prop, I don't know, Dan, if you can see that very well. Yeah, that's pretty good. So you can see here the galvanizing isn't completely removed, okay? But here I took a file belt and you can see the galvanizing is all off of there. So you can see the difference in color between the two. So we're actually starting to use the terminology bright steel. Okay. You want to grind that down to bright steel so you've got no kind of coatings on that surface at all.
Okay, cool. All right, I'm gonna put a request out there for last couple questions here. If we got any other questions, with a little bit of time left, if you have some more questions. In the meantime, I do have one question that, again, is a question that I've been asked several times over the years is weld bonding through cured versus uncured adhesives.
Good question. So we recommend in all our directions for use weld bonding through wet adhesive, okay? There are some adhesives out there where they actually say you can bond through them after they've cured. I've tested some of them and it's very questionable to me, okay? They don't look real good when you break them back open and look at them. It looks pretty charred and burnt. So I really don't get that, to be honest with you. So ours, we always recommend welding through them while they're wet, okay? The one thing you're going to notice when you're doing that is just from the heat of the spot welder, it actually cures a little quicker. So you have to be prepared and make sure you get that panel on there in time and just keep an eye on your work times and your cure times when you're doing it. But yeah, always through wet adhesive. You get much better conductivity, and it forces that adhesive when the welder tips come together. It kind of forces the adhesive out of the way. Whereas if it's cured, it doesn't do that. Sure. It's trying to push that current right through the adhesive.
So trying to get some blowout and stuff like that.
Exactly.
Point as well.
You mentioned a key point in both your statements here. Can you talk a little bit about the proper wet out of the material when you're bonding two panels together? Because this seems to be a question that still comes up. Just had one a couple weeks ago where they were only applying the adhesive to the panel that they were putting onto the vehicle. Right. So what are the proper processes in which we're putting adhesive on to put, say, like a quarter panel onto a car?
Yep, exactly. So if this is my bonding flange here and this is my replacement part, we're going to clean, just like I did here, clean this flange. We're going to apply adhesive to this flange and spread it out to cover all the bare metal. We're going to do the same on the replacement part, apply it, spread it out, cover all the bare metal, Then we're going to put one more bead on here. We kind of call it the squeeze out bead, because once that bead goes on and we put these two pieces together and clamp them, you should get some squeeze out along that flange. As a matter of fact, here's a great example. So these are two panels that are bonded together, and once we squeeze these together, you can see the squeeze out coming out of that area right here, okay? So it's always 3 applications of adhesive, which, by the way, is why we have a pneumatic applicator, because if you're doing a large van roof or something of that nature, to go 3 times around that is pretty hard to do with a manual applicator,
no
okay?
doubt.
As long as we're talking about squeeze out, I want to mention one other thing. So this is a good example of a, let's say, a quarter panel. So this is 2, sorry Dan, but 2 panels that are put together, right? So you put your adhesive on both of them, like we just talked about, both flanges, and then we put our squeeze out bead, and then we go and put these together. Well, there's a couple things. Number one, you technicians out there know what I'm talking about. When you put these together and try to put your quarter down, a lot of times there's interference at the top of the quarter where it fits really tight because you have to hang it over the trunk trough or whatever it is. So be careful that when you do that, you don't scrape all the adhesive off of this area. I've seen many of them where the adhesive is all forced to the very back of the panel and there's nothing on the flange, okay? So if that's really tight during your test fit, take a duckbill pliers and bend the inner up a little bit and bend the panel itself down just a little bit. Don't distort it or anything like that, but just give yourself a little bit of clearance so when you put these together, you're not gonna scrape all the adhesive out. Now, the most important thing though, is when I do get this squeeze out along here, we don't wanna let that cure and then take a grinder and grind this edge. Because you can imagine now when this edge is bare metal along here, how many painters are gonna be able to get their gun from the inside and spray outwards and get coverage onto that lip. I see a lot of these where the corrosion starts on that very lip and then just creeps its way in. So try to clean that off while it's clamped with an acid brush between the clamps or whatever, so you don't have to grind it at the end.
Okay. We do have a PPE question here for you. I know this isn't exactly your area of expertise, but I think you'll be able to handle this one. I've seen debates on organic vapor respirator is safer protection even over just when PPE only requires protecting against particulates. Does that make sense? We're wearing an organic vapor respirator. I've seen debates on organic vapor respirator is safer protection even over just when it requires particulates. So a commentary on wearing an organic vapor respirator versus a particulate respirator for when it's only calling for particulates. Is that?
Are they talking about for the process of?
Okay.
For the
All
process.
right, we're not gonna.
grinding?
We're getting waved off on that.
Yeah,
one, so, all right, no worries.
We're not probably the guys that talk about safety.
Not a problem. Okay, cool. All right.
We use them, but we can't give you the science
can't-
behind
yeah.
it. You know?
There's a
We've
whole
got other
safety
people-
team here. Yeah.
Jason, if they really want to know, we do have other people in our division that we
Okay.
can get them in contact with.
Okay.
So
their
that
rep.
they can, or their rep that can get them that information because
Okay.
we want to make sure that our customers are using the, being safe and using the proper PPE
Okay,
in
well,
the right instance.
Well, I'll tell you what, Josh, send either Kristen or myself an email. We'll pass it on to these guys, and then we'll try to get it to the right people to get that answer. So
Yeah.
apologize for that. So good,
Oh, that's
good
all
stuff.
right. It's
Good
the
stuff.
whole point of this, right?
Yeah, right.
Nothing can go wrong when it's live.
Right, exactly. Well, guys, it doesn't look like we have any more questions coming in. I want to thank both of you
Before you do
for
that,
your help.
I want to touch back on
Oh
this
yeah, I
here.
forgot
So,
about that.
See,
how are we looking here? Okay, perfect. So, what we hinted at in the
Nice.
beginning, right, and what Sean talked about, and I want to touch on this, where he talked about removing the material around the weld zone. You'll see that he doesn't have a perfect circle on here for each and every one, right? And when we make a weld, some of this material might be burned around the edge, but how are we protecting that? So when we refer to the wicking or capillary action, you can see if Dan can get I'll see if I can help Dan get a good camera angle. There,
Down a little bit. There you go.
right there. Okay, so you see right here.
You want a marker?
Yeah, actually, can I? That'd be great. So you see right there is actually the wet material. If I get it in that light again. There it is. So there's wet material that, while we've been on this broadcast, has already risen that far up that panel.
That's crazy.
Right? And so it's an awesome visual for people to see because they know that when they apply it directly to the metal that it's proper protection. We've talked about this using the cavity wax wands in there, but how is it getting in between these flange areas where we've welded right? Or these MIG welds where it might be, you know, not perfectly flat on the backside. That capillary action is what's taken place. And we've been here for just about 60 minutes now, and it's gone that far up a 5-inch coupon, basically defied gravity.
That's pretty incredible.
And it's wet, and it's not on the outside. It's actually in between the two panels.
So something to think about. Earlier we talked about FCA recommending to not use any weld-through primer.
Yep.
So think about that if it's an area where you couldn't squeeze type weld, and you, well, even if you were squeeze type welding with FCA, so you have bare metal in that flange where you've welded, how's that going to get protected? That's exactly how. So as long as you get that cavity wax, three good heavy coats in there, it's going to creep into those welded areas and surround each and every one of those welds through that capillary
Say
action.
that again, through 3 coats, right? That's the
Three coats.
3M
Yeah,
recommend is 3 coats.
Three
Recommend
coats.
three
As we're
coats.
looking, we want to make sure we achieve that 30 mils of build. And
Yep.
three, you know, medium passes to you is going to be different
Sure.
than 3 medium passes to me and 3 medium passes to Sean, right? The rate at which we're drawing back that wand or the rate at which we're applying it. So what we were looking for is 3 coats to make sure we've got that adequate build so that we can protect our repairs for the life of the vehicle.
Wonderful.
Is there a nozzle?
All right, so that's it for questions coming in. So again, now I want to thank you guys both for your time today. It's always a pleasure to be here at 3M, and thanks to the entire 3M team for allowing us to be here today. Again, this is our monthly collision repair technician 20 group, the only one in the industry. We'd love to have you join us each and every month. Right now, we're working on a vehicle manufacturer for our December meeting, and chances are we're probably back here sometime next year because I think this went pretty well. So
Come back
maybe come up
anytime.
with some new stuff here. So thanks for that. Also check out the Collision Hub Pick Attack feature. If you haven't subscribed to that, we love that. It's been going great. We've been getting great reviews on that, and we've been forwarding a lot of questions even to these guys. When we get questions that we can't answer, Christian or myself or Larry or others have been reaching out to 3M, different tool equipment, product manufacturers to get questions answered for you. So check out collisionhub.com. Subscribe to our Technician 20 group. Check out Pick Attack and stay tuned. 3mcollision.com, the 3M Collision YouTube page.
3M
Subscribe
Collision
to that.
Academy.
3M,
Yep.
So a lot
A lot of
great
information
resources.
available out there.
Yeah.
Just got to know how to get to it and
Absolutely.
subscribe so you get up to date.
And we'll keep pushing that and moving that forward. And again, guys, thank you very much for your time. Really appreciate it. It's always a
Jason.
pleasure to be here. So
Absolutely.
until next month, signing off from 3M. Have
Thanks,
a great
guys.
afternoon, everybody.
Thanks a lot.